Hello everyone and welcome to another episode of Investigation. In today's episode of Investigation, we will put our competition math aside for a while and let's take a look at some of the basic college math, specifically derivatives in calculus. And in this video, we will define derivatives using the idea of limits, and I will go over some intuitive views for limits as well, but just keep in mind that it is not a formal proof using delta and epsilon. And let's get started. And don't worry, and I will go over every single question in the AMC set when that comes out this year. So that's good. And we know that AMC 10 and 12 is going to be on November this year. So that's interesting, and we'll see how that plays out. So the first idea in calculus that we encounter would be limits. In limits, what we have basically, if we have a function over here, and if we want the limits of that, for example, if there is a limit of a defined value, that will be, most cases, that will be the defined value. But if the defined value, let's say, it looks like this, then the limit, let's say, for example, this is the coordinate 3, 3, and this is the coordinate 6, then we have that the limit would just be, so limit as x approaches, we have 3 over here of this function f of x, for example, that would still be 3. And we have another concept, basically, that if, for example, you have a piecewise function, I'll just draw like this, and if we have something like this, and that will be undefined at this point. So let's say this is, 2.5, and limit as x approaches 2.5 of g of x, if we say that this will be g of x, that would just be undefined. And that we can break it up into two parts. Let's say the limit of x approaches 25 in the negative side. So in this side, let's say this is 8, then that would be 8. And if it is limit of x approaches 2.5 in the positive side, then that would, let's say that's 1.5, that would just equal to 1.5. So that is the whole idea of limits. And if, let's say, there is some arbitrary function h of x, and at this point it is undefined, as let's say at some point it is undefined, it is still, let's say the limit of that would still be that y value. So that is the overall idea of limits. Obviously I didn't formally prove it, and there are lots of properties of limits, but the whole idea of this series would be going over derivatives rather than limits. So let's take a look on how derivatives are defined. So derivatives are basically, if we have a function, then if we want to figure out the rate of change of this function, which is mostly used in physics, and if you don't know, calculus is mostly developed for physics, because there are lots of concepts that in calculus that can be applied in physics. And this curve, let's say we want to find the instantaneous slope at, let's say, x equal to 3. This is f of x. Let's say that is equal to x squared. So x is equal to 3. We want the instantaneous slope of that line. And how do we find that? We find slope using formulas. Let's say for the slope formula would just be y2 minus y1 over x2 minus x1. And what we have over here, y2 minus y1, we definitely cannot let the x2 minus x1 be equal to 0. However, it can approach 0 if we defined it as a limit. And that is one of the definitions of derivatives. It is the instantaneous slope, basically, of that point. And that, if we have, let's say, if we have an arbitrary point, if we want to find the derivative of x of f of x with respect of x, then we create an arbitrary point a that approaches x infinitely using the idea of limits, and that value will be f of a, and that limit dx of f of a. So basically find the derivative at point a. That would be equal to what we have here. We want the limit, so that would be equal to as limit as x approaches a, we have x minus a under so f of x minus f of a over x minus a, and that is our definition of limits. And that is also sometimes written as f prime of a. And very, very rarely we see that it is written as a power with parentheses like this, but it's very, very rarely, and it is only expressed like that if there's a lot of derivatives being taken, like take that derivative once again and again and again. But we are just looking at single derivatives over here, and that is our definition of derivative. And also there's another. So if we say that the change is almost 0, then we can have limit as the delta of x approaches 0 of that, the delta of x. So basically the delta of x, and the numerator would just be x plus the delta of x minus f of x. So these are interchangeable, and these are basically the same, but there are different ways to express that. But the whole idea of limits or derivatives, the whole idea of derivatives would be finding the instantaneous slope of that point in a function. And that brings us to not differentiable functions. So some functions have parts that are not differentiable. Let's just draw some examples of that. First example is that if it is not differentiable at points of like sharp points. This point is not differentiable because if you approach it on this side, the slope would be something like this. If you approach it on that side, the slope would be like something positive, and that would make a disagreement, and the math world just says, okay, we're done. We're undefining it. This is not defined. And that we have another case where, well, this curve is not continuous. So at this point, it is not differentiable either. So if you know that a function is differentiable, it is most likely to be continuous. But if it is not continuous, just as this point, if it is continuous, it might not be differentiable. That is all we have for you in this video, and in the next few videos that I will post throughout this period, we will go over the rules of derivatives, such as the power rules are very important, and we have like 30 rules to go over, so keep that in mind, and they're coming. And thank you for watching this episode of Interestigation, and I will see you in the next one. Peace out.